All right, so we're going to go 6-3 and 6-5 today. They're kind of related fairly closely, so put them all together. All right, so 6-3 is special quadrilaterals. You got a rhombus, a rectangle, and a square. So a rhombus is a parallelogram with 4 congruent sides. Rectangle is a parallelogram with 4 right angles. And a square is a parallelogram with 4 congruent sides and 4 right angles. So we got these corollaries, which basically just restate what the definitions tell us here. A rhombus corollary: quadrilateral is a rhombus if and only if it has 4 congruent sides. Rectangle corollary: quadrilateral is a rectangle if and only if it has 4 right angles. And the square corollary: quadrilateral is a square if and only if it is a rhombus and a rectangle. All right, so that square fits into the category of a rhombus and a rectangle because it is a parallelogram. It does have 4 congruent sides, which makes it a rhombus. It's got 4 right angles, which makes it a rectangle. So the square is kind of the combination of the two. Now, in the homework, there'll be a section where you're naming all possible names that could be identified by a figure. So if it was a square, if you had a square there and you wanted to name all the possibilities, one, it's a quadrilateral because it's got 4 sides. Then it would also be a parallelogram. It's a rhombus. It's a rectangle, and then it's also a square. All right, so under the title square, there's actually 5 possible names that you could put down for it. Then a couple of theorems here. Theorem 611, a parallelogram is a rhombus if and only if its diagonals are perpendicular. So if the diagonals are perpendicular and it's a parallelogram, then it's also a rhombus. Right? Or if we know it's a rhombus, then we know that those diagonals are going to intersect at a right angle, perpendicular. All right, theorem 612, parallelograms are rhombus if and only if each diagonal bisects a pair of opposite angles. So the diagonals are going to split the angles in half if it's a rhombus. So each side of that diagonal would be the same angle measure if it's a rhombus. And theorem 613, the parallelogram is a rectangle if and only if its diagonals are congruent. So if you've got a parallelogram and the diagonals are the same length, then it has to be a rectangle. Questions there, anybody so far? All right, so then on to the 6-5 stuff here. All right, so a kite. Not only can you fly a kite, but it's a recognized shape in geometry, which is that basic shape that you expect a kite to be, right? It has 2 pairs of consecutive congruent sides, meaning there are 2 different pairs of sides that are the same length, and those sides that are the same length are actually attached to each other. They come one right after the other. So you've got these 2 sides that are congruent, and then on the other end you've got another 2 sides that are congruent. And theorem 618, if a quadrilateral is a kite, then the diagonals are perpendicular. So if we know it's a kite, then when we put the diagonals in, they're going to intersect at a right angle. Theorem 619, if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. And those angles that are going to be congruent are going to be the opposite angles where the 2 different side lengths meet. All right, so you got a pair of congruent ones on this end, a pair of congruent sides on this end. Where those 2 different side lengths meet is going to be where the congruent angles are at. All right, so then trapezoid, another type of quadrilateral. It has exactly one pair of parallel sides. So you got one pair of parallel sides and then one pair of sides that are not parallel to each other. So the parallel sides are called the bases of the trapezoid, and the legs are the non-parallel sides. Now, this is the shape that we usually recognize. Most people say, oh, that's a trapezoid. But a trapezoid does not have to be in this perfect shape right here. Right? This shape is actually an isosceles trapezoid, which is a trapezoid with congruent legs. So if the two legs, the two sides that are not parallel, are the same length, you get a trapezoid that looks like this. But you could have a trapezoid that looks something like this. You still have two parallel sides, but the legs in this case are not the same length. So the main requirement is just that you got two parallel sides and two sides that are not parallel. All right. Theorem 614. If a trapezoid is isosceles, then each pair of base angles is congruent. So the base angles are going to be the angles at each end of the two bases. And remember, the bases are the parallel sides. So AB is one base, and so the two angles on each end of AB, angle A and angle B, would be congruent. Side CD is the other base, and so angle C and angle D on the ends of that base are going to be base angles that would be congruent if it's an isosceles trapezoid. Theorem 615, if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. So this is just kind of the converse of this one. Just saying, if this one tells us if it's an isosceles trapezoid, it's got base angles that are going to be the same. And this one tells us if we have base angles that are the same, then we know it's an isosceles trapezoid. Theorem 616, a trapezoid is isosceles if and only if its diagonals are congruent. So if the diagonals are congruent, then it's going to be an isosceles trapezoid, not just a regular trapezoid. And lastly, theorem 617, the midsegment of trapezoids theorem. It says the midsegment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. So, kind of like when we did midsegments of triangles, a midsegment just goes from the midpoint of one side to the midpoint of the other side. So we're going from the midpoint of one leg to the midpoint of the other leg. And then the length of that midsegment is 1/2 of the two bases added together. Or it's the average of the two bases, basically. All right. So now we're going to do a little math with these trapezoids and kites. So starting off solving for x, we have a trapezoid here, which we've got two sides that are the same length, making that an isosceles trapezoid. And if it's an isosceles trapezoid, then we know that the base angles are going to be congruent. So if this bottom one here is 62, then the other base angle on the other side would have to be 62. And if this one is x, then the other one is x. And so all four angles together have to add up to 360 degrees, right? Because it is a quadrilateral, and the sum of the angles of a quadrilateral is 360. So you can do x plus 62 plus 62 equals 360. 2x plus 124 equals 360. Subtract 124 from both sides. X equals 236. And divide by 2. X is going to be 118. All right, so then the next one is a kite. And what's the one thing we learned about the angles of a kite? Anybody remember? So remember, in a kite, you've got exactly one set of congruent angles. And those congruent angles happen where the two different lengths meet. So the two different lengths meet here. So X, and then the angle over here should be the same as well. So we can recognize that angle as X. And then we know that since it's a quadrilateral, they have to add up to 360. So X plus 122 plus 68 all have to equal 360. So 2x plus 190 equal 360. Subtract 190 from both sides. So we get 2x equals 170. Divide by 2, and our x is 85. So both of those angles are 85 degrees. So this next example here, we've got a trapezoid with a mid-segment. We know it's a mid-segment because the lengths on each side of the intersections are the same. And so the rule for mid-segment is that the mid-segment x here should be equal to 1/2 of the two bases added together. So 1/2 of 14 plus 18. So x is going to be 1/2 of 32. Or x is going to be 16. All right, so then over to this next one. It's another kite with one angle missing, but we know that the angles where the two different side lengths meet should be congruent. So we know this one's 125. So the other one up here should also be 125. Which then will allow us to know that we can add all that together to equal 360. So 125 plus 125 plus x plus 30 plus x equals 360. So it'll be 280 plus 2x equals 360. Subtract the 280 from both sides. So 2x is going to equal 80. Divided by 2, and x equals 40. So you got a 40 degree angle here, and what would be a 70 degree angle over here. And then the last one here is another mid-segment problem, trapezoid. A little bit different because we have an actual value for the mid-segment and the x's are in the bases. But we know that the mid-segment length is equal to half of the sum of the bases. So to set it up, we're going to say that 18 being the mid-segment length should be equal to 1/2 of the two bases added together. So x plus 2 plus x plus 8. So 18 is going to equal 1/2 of 2x plus 10. So distribute the 1/2 and we get x plus 5. So in this case, our x is going to be 13, which would mean that the top side would be 13 plus 2, or 15. Bottom side would be 13 plus 8, or 21. So that concludes the notes.